Okay, the final test I want to talk about is the BUN to creatinine ratio. And so the BUN to creatinine ratio is actually very similar to our FENA in many ways, except it actually makes the sort of same assumptions that we made above when we used serum levels to estimate clearance. And so one assumption here is still hypovolemia, because we're for this test to be useful, we're basically reassessing how much BUN is being reabsorbed, and in the context, reabsorption is really relevant in the context of hypovolemia when solutes, when osmoles are being, either through in conjunction with sodium, urea is often reabsorbed. And so that's one assumption. The other assumption here is also sort of a steady state assumption, at least in part. And what we're going to do here is we're going to say that, and so imagine if we said, we're interested in our clearance of urea divided by our clearance of creatinine, just like above, right? Because remember, urea and sodium are actually very similar in that they can be used as measures of our reabsorption. So if we say clearance of urea by clearance of creatinine, and now if we make the assumption, like we did above, that our sort of production rate and our, our production rate and our excretion rate are about the same, or in other words, that, we'd expect to be excreting a certain amount of urea and creatinine, there's some sort of, there's some steady state there, then we can kind of estimate our clearance of urea by sort of 1 over the plasma concentration. So 1 over P urea is a good estimate, or is related to this is like proportionality. So 1 over P urea, and we can just kind of look above to kind of remember that here we were looking at our creatinine clearance. Remember, creatinine clearance in the context of a constant production, the creatinine clearance is going to be related to the inverse of our creatinine concentration. And so if we say that, clearance of urea over clearance of creatinine is 1 over P urea divided by 1 over P creatinine, then what we can see is that, if this is basically equal to P creatinine over P urea. And so if our urea, so if our, actually this is equal to 1 over our BUN to creatinine ratio, 1 over BUN to creatinine ratio, let's call it BCR. I don't think that's a approved abbreviation, but okay, so basically what this says is that if our clearance of urea, so remember above, clearance of sodium divided by clearance of urea gave us a sense of our kidney function, our tubular function, right? So if our tubular function here is good, so when BCR is high, that means our tubular function is good. Right? That means we're reabsorbing urea. We're doing reabsorption in the context of hypovolemia, which is what we expect. And so a high BUN to creatinine ratio indicates, in the context of hypovolemia, indicates normal reabsorption. And, if individually BUN and creatinine are high, or creatinine in particular, remember, our CRM creatinine in the context of a steady state assumption can give us a sense of what our GFR, right? So basically, if our creatinine is high, and our BUN to creatinine ratio is high, which means that our BUN is even higher, this would indicate that we have normal reabsorption, and so this would be normal reabsorption and decreased GFR, right? Because our creatinine is still high. So this would point to a pre-renal dysfunction, right? Because we have normal tubular function and we have a decreased GFR. All right, that's all I got.